Okay, welcome back. We're going to start section 7.3 today. Section 7.3 is on hyperbolas. So the formula looks almost the exact same as they did in the last section for ellipses. There's only one difference. And so I'm going to look at x as the major axis. And when I do, the equation is going to be x minus h quantity squared over a squared and y minus k quantity squared over b squared equals 1. The difference is that it's now a negative. Okay? And so that negative changes how the foci are being produced, which then changes the property of the ellipse and makes it into a hyperbola. So let's look at that. Our center is going to remain unchanged. I'm going to use M again for the middle. Center is going to be at H comma K. And then I'm going to have my vertices. They are going to be at H plus or minus A comma K, just like they were. So this distance is A. Our foci are going to be at H plus or minus C comma K. But in this case, because of the negative sign, we end up with C equaling the square root of A squared plus B squared, which means that it's a larger number than A, not a smaller number. Last time it was A squared minus B squared. This then makes our foci be outside the graph. That becomes C. B is actually just a point in space. The graph doesn't go through it. Okay? And actually, I'm going to bring it down a little bit. Want it closer to the center. And that same distance down. Okay, so that's B, getting us down here to these points, but they're not the foci. They're not co-vertices because they're not actually a part of the graph. They're just kind of points out there. Okay, and we're going to find them because of how we need to draw the hyperbola. And the hyperbola, basically, we have our vertices and these points off of A and B, and we're going to take them, and I'm just looking for a color that's going to show up. Maybe this red will. And we're going to make a box. Where the sides of the box sit on the vertices and this distance on the minor axis. Okay? So we've got this box that the sides are A away from the center and B away from the center, respectively. And now, what are we going to do with that box? Well, we're going to draw lines on the diagonal of the box. So the diagonal should go through the center and out the other corner. And I'm going to draw these lines that come away from the box. Far more complicated of a graph than it was last time, right? What happens with hyperbolas is they go through the vertices again. They're being pulled towards the foci, and they come out and hug, but never cross those diagonal lines you just drew. Hug, but never cross. Okay, so the purple is our hyperbola. So not as much is needed to draw it as was in the past. You just got to know how to put all the pieces together, how to create that box. Okay? Last couple things we need to talk about is the transverse axis. Which is major, is y equals k. The conjugate axis I wanted to say conjugate acid because I taught chemistry for so many years, but the conjugate axis is the minor axis, and then in this case is x equal to h. And the last one here are the asymptotes. And that equation is y minus k equals plus or minus b over a times the quantity x minus h. And you're like, what is that? Y minus k equals plus or minus b over a times quantity x minus h. Well, it's a line, and it's these diagonal lines. They actually have an equation. And they go through h and k, and their slope is plus or minus the ratio of b to a. Okay? So that they go through the point x and h comma k, sorry, and they have a slope plus or minus that ratio of b to a. So let's look at one of them, y as the major axis. Very similar. Okay, for y equals the major axis, again, it's going to be, we're going to reverse it this time. It's going to be y minus k quantity squared over a squared. So the a squared is now with the y, but the negative one is the x minus x minus h quantity squared over b squared equals 1. We get all the same parts are parts again. We get that our center M is at h comma k. We get that we have vertices of h comma k plus or minus a. We get foci at h comma k plus or minus c. Our axes are reversed, so the transverse axes or major is x equals h. Our conjugate axis or minor is at y equals k. And those asymptotes are at y minus k equals plus or minus, the ratio changes. It's a over b and x minus h. Okay? To draw this, we're going to have our new center, but now we're going to find that our vertices are adjusting up and down. So we're going to get a vertice, a vertice. Foci are going to be even further out. And when we draw in all the parts, so those foci are at C, those vertices are only A out, and once we draw B out, wherever that point is, that creates our rectangle. Through which creates our asymptotes. And the asymptotes become basically the fence that keeps our hyperbola in check. So in this case now, the major axis was on the y, and so it's opening up and down, starting at that vertice and hugging those asymptotes. Questions? You're not here to ask them. Okay, so we're going to do a few graphing practices to finish off this lesson. X squared over 16 minus y squared over 9 equals 1. Okay. So the first thing we know is that x squared is positive. That means that we have x as the major axis. we have a center. There's nothing being subtracted here, so our center in this case happens to be at 0, 0. Our A is the square root of 16, which is 4. And our B is the square root of 9, which is 3. And so to graph this, a really simple graph, we draw on our axis, and our center is right there. Our major axis is 4, so that's left, four, right, 4. Our conjugate is going 3 away. And so that all is going to create this rectangle. And if you drew your scale as poorly as I did, it's not quite a perfect one, but it'll get the job done. The asymptotes, draw them in, coming off the corners. Usually we make it dotted. There, look at that, now it's dotted. And because it's on the X is the major axis, it's opening on the X. So it's opening from these foci heading out. Okay? Simple graph. But they're not always that easy. Let's look at the next one. Let's have x minus 5 quantity squared over 49 minus y minus 1 quantity squared over 17 equals 1. Okay? Again, x is on the positive, so x squared is the positive term. So therefore, we got an x as our major axis again. If that's the case, then that means our center is at 5, 1, 5 and 1. A is the square root of 49, which is 7. And B is the square root of 17, which doesn't do us any good because it's not something we easily graph, but we know the square root of 16 is 4, so we know that square root of 17 is going to be just a little more than 4 plus a little bit, right? Do we care what that little bit is? Not really, because these are just hand sketches 1 and 2. We just need to show that we went out a little past 4. So let's look at what that looks like. Our center is at 5, 1. So if I use this as my graph down here, we're going to be at 1, 2, 3, 4, 5, and 1. And we've got Our A is going out 7 from there. 1, 2, 3, 4, 5, 6, 7. And this was 5, so -6, -7 puts us there, -2. And then our B's are just about 4, a little over. So 1, 2, 3, 4, 5, and just a little bit, okay? So somewhere in here is gonna be our side. And going down for 1, 2, 3, 4, and just a little bit past it, okay? Because all we need is to know where the side of that box is. We don't need to know the exact value. So once we do that, we can draw in, oops, I'm off the graph, sorry. Large rectangle, because we went all the way out to 9, 1 here, and back to -2, 1, and then the sides were down 4 from the 1 and up 4 and a little from the 1. And then that gives us our asymptotes. You know, it's bad when my ruler's not even long enough to draw it. Okay, and we get, again, they're opening out try not to make this a point. Should be more curvic. And there's our hyperbola. 2 more graphs. Number 3 is, let's look at this one. 25y squared minus 4x squared equals 100. So we're not in standard form. So we got to get in the standard form. We need a 1 on the side. And so to get 1 on that side, we're going to divide everything by 100. And when we do, we get y squared over 4 minus x squared over 25 equals 1. Okay? Now we can find all of our pieces. In this case, we've got y is positive, so the y squared is positive. Therefore, we're on the y as the major axis. We have an a value is the square root of 4, which is 2. And we have a b value, the square root of 25, which is 5. So we're going to have it really short and wide rectangles being formed here. Okay? Again, they were nice enough to give us this in centered on the origin, 0, 0, because there's no number after x or y. So we have a center at the origin. And we're going to go out for A. We're going to go out 2. Now, A is under the y term, so we're going up and down this time on the y-axis. 1, 2, 1, 2. And for the B, we're going out 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And we get this rectangle. Okay, long and short. And so that's going to create asymptotes that are very spread out. Now remember, it's on the y-axis, so it's opening up and down. So we're opening here. It's going to be an extremely wide hyperbola. Extremely wide hyperbola. And our last graph for today. What happens when it's most definitely nowheres in any semblance of order? So we get a negative x squared plus 3y squared minus 4x plus 6y equals 28. Blech. Okay, first thing we're going to do is put that beast into standard form. So y is positive, x squared is negative, so the y term's got to go first. So I'm going to pull up the 3y squared plus the 6y, and then over here I'm going to put my x terms, my negative x squared, my minus 4x, and if my number's not on the right, I would move it to the right. So I have 28 over there. Okay, move my equal sign over just a little bit, so I have some room. Okay, and now we get to work on completing the square. Again, we have to take a 3 out of here, because we need that y squared by itself. Y squared plus 6 divided by 3 is 2y plus some 1. And then we have to factor out the negative off of each of these terms so that we have in the inside a positive x squared. And so a negative 4 divided by 1 is a positive 4. Next term to be determined, and our 28. So the trick with these is that we're going to end up with a number we're putting in here that we got to actually do the opposite for on the other side. The opposite to compensate for this negative in front. Okay? So the 2 divided by 2 is 1. 1 squared is 1. So we're adding a 1 here. That is 1 times 3 is 3, so we're actually adding 3 to both sides. Here, the 4 divided by 2 is 2. 2 squared is 4, so we're adding a 4, but really we're adding a negative 4, so we're subtracting a 4. This gives me 3 times the quantity y plus 1 quantity squared minus the x plus 2 quantity, x plus 2 quantity squared, and the 28 plus 3 minus 4 gives me a 27. Remember, we can't leave the 27 over there, so we got to divide everything by 27. And we're left with y plus 1 quantity squared. 27 divided by 3 is 9 left on the bottom. Minus, there's nothing to reduce here, so it's just the x plus 2 quantity squared over 27, and that equals 1. So we wrote it in standard form. Yay! Now we can graph that. Okay, I'm going to need a new sheet of paper, so I'm going to just slide this up so I have some more paper to write on here. Okay, there it is. And now to graph this, remember if 9 is a squared, so if a squared is 9, then a is 3. And if b squared is 27, then b is the square root of 27, which square root of 25 is 5, so this is going to be just over 5. All right, it's going to be somewhere between 5 and 6. You can do it on your calculator. You can get a nice decimal number. That's fine. But for graphing purposes, we don't need it. Okay? My center is going to be at -2 and a -1. Got to take it from the x and the y where appropriate, right? So the x term has the h, which is 2 negative, and a -1. So -2, -1 is our center. It is opening top to bottom, so the a is going up and down. So a of 3 means up 1, 2, 3. Or down 1, 2, 3. And then our b term is out 5. 1, 2, 3, 4, 5, and just a little bit over. And 1, 2, 3, 4, 5, and just a little bit over. And we draw in our box, and we find those asymptotes. And it's opening wide, remember, because y was the positive, so it is opening up and down, which means it looks like this. So another wide one opening up and down. They're not all wide opening up and down. It just happens that these two examples were. Okay, and there is our hyperbola. Okay, that's it for today. Next time we will talk about how to come up with the equation with different given information, and we're going to talk about how to identify which of the 4 conic sections something is without going through all the hassle of putting it into a standard form. Okay, I'll see you next time.